We did make it to part 4, ladies and gentlemen. I'm super excited for this because for this particular part is one of my favorite parts, right? We're going to be going into the weeds of our algo strategy, right? We want to find the best parms for the strategy such that it can perform the best as possible when it comes to actually paper trading this and then eventually putting real money behind it, right? So we're going to be using a little bit of machine learning vis-a-vis Optuna and then doing our optimization slash tuning in order to find the press parameters slash configurations for this AI breakout strategy that we created. So for those that don't know, my name is Creative, and here at Creative Coder, our aim is to create different algo trading strategies, algorithmic trading bots, right? And different cool coding projects that I share with y'all so y'all can see my process. I've been doing this for a little bit over a year, started May of 2025, right? So I still consider myself super new in this, and I've only been streaming since about October of 2025, right? So I wanted to get a little bit months behind me before I started streaming. So now I'm just sharing with y'all my process on how I go from ideation, right, back testing, and then now we're at the machine learning and optimization part of this algo. Now, one thing that I didn't do before, oh, if you haven't already, go ahead and smash that like and subscribe button. I always forget to do that part, whatever. But one thing I know I didn't do last time was being able to break down the Kalman filters, KAN, and then the MAE breakout bands, right, and how they work here, right? So what I want to do is just take this. Let's go ahead and jump over to ChatGPT. And then we're going to say you are a senior Python quant developer that specializes in 0DTE options strats. And you are a tenured professor that is able to take any complicated topic and break it down for your students using analogies and simple sentences, not over explaining. We need to understand how works and what is the difference between all three of these indicators and how they can work together. Keep your response to 5 to 8 sentences with a visual. All right, beautiful. So the Kalman filter, right? So this acts like a noise canceling headphone for the price. It listens to every ticks but filters out the random market chatter so you only hear the real trend. And trend is going to be what direction the underlying market is going in, right? Then we have the KNN smoothing, which is the KN nearest neighbors. It's like asking it's like asking the last few most similar market moments. What usually happens next? It smooths out the price based on that patterns that looked alike before. Then we have the MAE breakout bands. It uses an average of error distance around the price, kind of like a flexible guardrail on the highway. When you punch outside of the rails, the signal momentum may be expanding. The difference is that the Kalman is the trend cleaner, the KAN is the pattern smoother, and the MAE bands is going to be the breakout detector. All three used together. Kalman helps you stay with the real move. KAN confirms whether this move resembles a strong prior setup. And then the MAE bands tell you when the price is breaking hard enough to justify the entry. So think of it like driving. Kalman cleans the windshield. That's funny. KAN checks the GPS, and the MAE bands show you when you're leaving the fast lane enough to accelerate. I don't want to cough in your ear. Excuse me. Excuse me. So here's a visual of how it works. So here's the price action, and then Kalman filter go ahead and cleans that up for us. And then the KAN smoothing is going to confirm the pattern, and then MAE bands is going to look for the breakout. So our entry is going to be Kalman trend, KAN agrees, and the price breaks the MAE breakout, and this is the possible put or call setup. All right, bet. So now we understand that, right? So what I want to do now is being able to find the best parameters for this particular strategy such that we are able to make it perform as optimally as possible, right? So I was using an old Claude Code session. Where I'm at right now, I'm at 78%. What I want to do so we don't lose this is I want to have it create a strategy overview document so we can just, matter of fact, I don't need to. Let me do that at the end. All right, so I'm going to hit exit, clear, beautiful. We're in Opus. Where are you? AI baby breakout. Review the following strat and also review the results. First, make sure you get how the strat works and the results we were able to get so far. PS for 2022, this is due to data availability, not really a strat issue. But what we are looking to do now is optimize the parms such that we have the best available ones for us to paper trade and validate this strat. Advise if using Optuna is an option here, or if we can do this manually. Explain and keep your response to 5 to 8 sentences and take pride in your work. Beautiful. The whole take pride in your work thing. Now, y'all notice I didn't do the whole you are a senior Python developer. Reason being so is because there's a couple of things that's already auto loaded into Claude's memory, right? With that whole being able to preface it and all that. So that's already one of the things that's auto loaded. So I don't need to say that. It's just a matter of being able to say, what do I need? How do I need to get it done? This is what I'm thinking about doing. Does it make sense? Or can we do this manually? Right. So what Opus is doing right now is being able to go through all of our results. What happened? How did it look? What are we seeing so far? And then what is the next best step forward when it comes to being able to optimize our strat here? All right. So I've already went through the strategy architecture, so I'm not going to bore y'all with that again. I hate these errors, bruv. You are getting yourself caught up with errors. Okay. Optuna is absolutely the right call here, but I strongly recommend it over manual tuning. You probably have 10 turnable parameters, which is the Kalman R, QP, and the QV, K and length, the band lookback and multiplier, and then the exit thresholds and the time stops, which creates a search space too large for a manual grid search. Optuna TPE sampler will effectively explore this space while pruning out bad trials only. The key is using walk forward validation, training on 23, validate on 24 first half, then test on 24 second half to avoid overfitting, right? Which with results this strong, the risk of curve fitting is to historical QQQ behavior rather than capturing the real edge. I'll optimize for the objective like profit factor or times trades to balance out the quality of trade frequency and constraint search so it doesn't produce degenerate configs like TP 50% with 1 minute time stops. Degenerate configs. That's funny. All right, hold on. Excuse me, trying to cough in your ear. I saw that error, so let me come here. Boom. Resume. All right, let's get this done. And let's make sure that with each trial, right, we are using pre-index and vectorizing where possible. So this doesn't take super long to get done. So we understand, right? So let me come here. come to this codex. Can you explain how Optuna works, and is it like machine learning or no? Keep your response to 5 to 8 sentences. Remember, Codex is going to be OpenAI's version of Claude Code. So what it is, it's like a coding assistant, right? Hold on, it's looking for Optuna, and Optuna is in here. Search should be here. It's like Claude Code, but it's specific for OpenAI, right? I only use it when it comes to being able to talk through a few different things and like flesh out a couple of new ideas, right? But when it comes to the coding, I only let Claude Code touch code, right? And Codex, you can just talk me through some shit. All right, beautiful. So you're creating that. Excuse me. Hold on. I finally decided to drink some water. Hold on. Like I got a frog in the back of my throat. Pause. Excuse me. So Optuna is a Python library for hypertuning for tuning hyperparameters, which means it helps you find the best settings for your model or algorithm automatically. You define an objective. Inside, the Optuna tries different parameter values, runs your training or evaluation code, and records the scores. It uses a smart search method like based on optimization and pruning, so it doesn't just guess randomly forever. Pruning means it stops weak trials early to save time. Optuna itself is not a machine learning model. It's more like a tool that helps machine learning models, simulations, or other optimization problems perform better. So it uses machine learning a lot, but it is not machine learning itself. So we get Optuna. Beautiful. So now we're creating the Optuna file such that we can find the best parameters for this strategy that we are creating, right? Um, yeah. So I'm waiting for you to do that. I'm waiting. We already have the explanation for this. All right. Question here. Question. Would it make sense to seed Optuna with the parms we have so far? And how can we make sure we are getting the most out of it and not making any rookie mistakes? This is our first few times being able to use Optuna. Don't assume. All right, beautiful. So we have our Optuna. Optimized file is right here. Why pre-index matters. The original backtest scales the full Greek library, millions of rows on every find call. The optimizer, builds a dictionary keyed with data types, timestamps right at the load time, blah, blah, blah. Okay, beautiful. So that's running faster. Let me smoke test it. Go ahead and run 3 trials. This makes sense to seed options with the best parameters you already have, especially if you, if it came from the objective data set and training values. And Optuna usually means enquenning. What the fuck? Yeah, I'm not going to hold you. If I don't know a word, I'm not going to.
Enqueuing.
Enqueuing. The process of adding data or tags to the back of a queue line or data structure for sequence processing. Enqueuing, known good trials first so that the search starts from real signals instead of spending early trials discovering obvious baselines. To get the most out of it, make sure that the search space is deliberate, keep it tight enough to be realistic, use log scales for things like learning rate, and avoid tuning parameters that barely matter. The biggest rookie mistake is treating noise results as the truth. So keep validation consistent, fix random seeds when possible, and then compare against a strong baseline. Another common mistake is running too few trials or pruning too aggressively, which can make Optuna look smarter than it actually is while missing the better regions. Also, make sure that the objective function reflects the real goal because Optuna can only optimize what you actually measure. If you want, I can show you. Okay, beautiful. All right, so you're running Boom. All right. Review our strat. Here you got to paste our strat and the Optuna file we have. Then let's discuss, SWOT, and grade it objectively, and cite your sources and rationale. All right, you're still going. So now that I know, it takes, I don't know what it is, fam. Maybe it's this damn ginger ale. I'm reviewing the strategy code, the optimizer, the Optuna related files together so I can assess the actual search setup. Okay, I have the main engine, the optimizer now. Now I'm checking whether the optimizer is actually optimizing the same behavior as the live backtest, because this usually where false confidence creeps in. There isn't any existing Optuna output artifacts under Algo baby yet, so I'm treating optimizer as an Optuna setup to review unless another result file you want me to do. So I'm pulling the baseline backtest results so I can grade it and tie it to the observed behavior, not just code structure. You're still running. And this is why I like having both of these, right? So while one is running, I can ask my questions to ChatGPT Codex, quote unquote. Now I have the baseline 2023 and 24 curves are extremely aggressive. So I'm quantifying the profit factor, drawdown, and the return concentration next to see whether the edge is real or just leverage plus unfavorable regimes. Optuna official, okay. Best practices. I love this. You're actually reading the API docs. Reading Optuna's API. Okay, I appreciate that, fam. You're still going. A bit of a process, yeah. I found likely structural bugs in the optimizer. I'm verifying the execution before I call it out. The objective appears to reset the account balance per year, but still computes the drawdown across the concatenated balance series. If that holds true, the optimizing target is materially misscored. Yeah, you're not going to find it. You got to use oh man, Jit is gonna be tripping. You're still running? Okay, you should be wrapping up soon. So you see we have our scores coming. Okay, beautiful. You only took 4 minutes for 3 trials. Worked perfectly, 2.7 seconds per trial, meaning 200 trials equals 9 minutes. 500 trials is 12 minutes. Already in 3 random tests, found it configured with Pt4 and baseline of 6.2. Okay, beautiful. All right. Early signals, even with 3 random samples, trial number 1 already beat the baseline by lowering the multiplier from 1.2 to 1.6. More signals, arming earlier 4.5 instead of 8, and using a wider trail, which suggests the baseline is leaving money on the table by using too conservative trail activation. All right, go ahead and run the full. I think I'm going to run 100 trials. Okay. Finding Optuna's Optuna objective is misscored in the balance is created once, but in the optimizer it resets to 0 each year. Then the max drawdown is computed across the combined balance and the Optuna. This means that all right, hi, the search is fully in sample. The sample data set built from the years in the Algo baby, is used for both optimization and the optimizer for the final best comparison in Optuna. This makes overfitting the main risk. The baseline outputs are strong in 2022 and 23, but only 24 has 2 trades versus, this is not enough validation. Breath for meeting with the optimizer report sharp is not a real daily sharp. In the optimizer, it only tracks P&L on trading days, while the actual backtest log every day is it does not change the current score, but it makes sense to diagnose noisy. Okay, beautiful. BBC, fix this, fix that. Here's the sources. All right, beautiful. So what I'm going to do, I'm going to take this. All right. Then I'm going to copy. And I'm going to come here, review, double check. If this is the case, let's fix before we run it. That's how you can use one AI to be able to verify another one. Work smarter, not harder, people. All 4 findings are confirmed. Here's what's real. Scoring bug, end sample only. Okay, let me go ahead and put you on auto. No baseline. Confirm. Study starts code. Okay. So now it's fixing all of these items. Then once it's fixed, then I'm going to run 100 trials. And then once we run these 100 trials, then we'll be able to find the best parms for this particular strategy, right? And you can see this is a marathon, not a sprint, right? We want to be able to make sure that we take our time to be able to get this done. There are some parts that are monotonous. I'm not going to hold you, but you would rather take your time and do it right now than get it wrong live in the field. So I treat this as practice, right? I'm putting up my shots, right? Or I'm at the jug machine, being able to get in my catches, or I'm at BP, right? Like however, whatever practice you want to be able to go through, right? Like this is what I'm doing right now. Like I'm just putting in my reps right now to be able to get better when it comes to this algo gang, man. I think we all can be. Okay, smoke test to make sure the fixes work. That 3 trial thing, fam, is crazy. Hold on. Run 1 trial and advise if it works. All right, beautiful. Now we're going to run 1 trial because remember, 3 trials damn near took 4 minutes. So this 1 trial should only take a few. All right, bet. So I'm going to do is come here. All right, Gucci, we made a few changes. Review our code now and advise. All right, so I'm gonna let you go. I'll see it takes a little bit to be able to run these trials. So it's depending on how long it takes. Like we may have to push this to a part 5 because we are pushing on 22 minutes now. Oh shit, hold on. I keep forgetting to tell Jit. Run in freaking A. Run in using Python, not Python 3. See, I may have to. Good thing I only told you to do 1 trial. That 1 trial, look how long it's taking. All right, beautiful. Who's gonna go? Who wants to run? I'm still waiting to see who's gonna be the first one to jump. The import checks clean. The 1 trial is still running, which is expected because it has to preload the 2023 data and the data. Oh shit, are you running it too? All right, both. Damn it. PS/PS. Um, stop. There we go. That's interesting. It's taking more. That's crazy. All this time that it's taking to be able to run. Yeah, fam. I'm not going to hold you. This is probably going to be a part 5 when we want to pick this up because just running 1 trial is taking this long. All right. What I want to do is go ahead and take the command. Hold on. Where is it? Where is it? Where is it? Here you go. Boom. Copy. Where you at? You're still going. All right. Clear. Boom. All right. I'm going to do a little 100 trials, right? 23 and 24. Data. Data. Damn, bruv, you still going? That's how I know this is going to take some time. Lie to me again. You tell me it's raining. Excuse me. This is crazy. All right, let's go make note of what we did, what we're doing right now. So part 4, it's IV, right? Yeah, this is 6, this is 4. Yep. All right. We are working on finding the best parms and configs using Optuna. Just found out that each trial can take up to 3 minutes, right? So we are going to run it and pick this up in part 5. See? Bruv, it's still going, bruv. Look at that. It just finished, bruv. That's one trial. All 4 fixes are working. Did you save? Smoke test. Okay. So train and then validate. Beautiful. Baseline score stayed the same. Single confirming no. Sharp rate drop because now it includes the 0 okay, which is the honest number. Baseline seeded. 0 trials is the baseline number, is the exact match. So the TPE starts with the known good territory instead of 20 random warm-ups. The sharp is corrected. Okay. All right, now let's run it. All right, so what it's doing, it's loading the data, and then it's going to actually do this. So I'm going to let y'all see one, right? Then I'm just going to let this run, and then like towards the tail end, I'll pick this back up so we can actually see how well, or excuse me, how efficient or what the results of this is going to be. Bro, why is it taking so long to load the data? Hold on. Wait. Are we using pre-index or to load the data? Trying to get why it is taking so long to load the data. See how the backtest does it and gauge if we can steal any methods or functions from it such that this optimization runs a bit more faster. Now, if it is good, just say that. Don't overcomplicate this, brevy. Let's see. Roosting. Let's see. Still thinking with medium effort. It's not like we're waiting for you or anything. All right, the data loading is DuckDB reads it identical to the backtest. That's fine. The bottleneck is the Greek load. Rose is using, okay, which is the slow part. It iterates through it. Yep. Go ahead and vectorize that for me, buddy. Vectorize is being able to make sure that it's a no. Fuck no, I'm not gonna let you do that. I'm gonna do it. I'm gonna copy you. I'm gonna clear. Then we're gonna paste. Then we're going to run it again. Then it's loading the data. All right, it's not like we're waiting for you or anything. You know what I should have did? I should have put time in front of that. Damn it. I have these revelations not until after. That's dumb. That's crazy. Okay, here we go. Here we go. Let's fix. Oh, Greek loading. Wait. I gave you this data, bruv. Where is it? This why sometimes you got to be able just to double back with them. And let's fix it, bruvy. Come on now, bruvy. Whisking, if you would. I've only been, and like these last 2 or 3 minutes, I'm not going to hold you. It's just a little bit of QA, right? A little bit of quality assurance to be able to make sure that the code that we're spitting out is actually legit and it works. I mean, it could have been a couple of things that I could have prompted this to be a little bit better. I'm not going to hold you. I was a little bit lazy. It's too many in memory. Fast bit lookup without. Okay. Okay. Now we should be Gucci. For real? For real? For real? All right. This should be working now. I want y'all to see just one trial so you can see it live. Then I'm just going to have it run towards the tail end. That's when I'll pick back up for part 5. Come on, bruvy. Holy shit. Y'all see in real time. All right. Take pride in your work. And let's get this done and make sure you ship us the quality fix and not just some heuristic patches. I'm at 44%. You tripping. You're right. I left out the stale reference. Let me find all the references and fix them all properly. Let me verify that there's no other stale references. Let me do a quick sanity check. All right. While you're doing your sanity check, let me do that. Come here, clear, paste you there. I wish there was just a little bit more feedback. Anthropic, if you're watching this, I don't know how, whatever, but if you are watching this, if we can get feedback as to what is going on, what is happening, right? And I'm not left in the dark and it doesn't capitulate like this. Okay, no crutch. Then that'll be so much better. All right. Let's slide. Let's see how you move. I want to get you to work so we can groove on the dude. I don't know. Sometimes I'm just waiting. I become a rapper at this point. I appreciate y'all patience, man. I promise this is quality stuff we're doing here, bruvy. Quality stuff. Here we the fuck go. Now we're loading 2024. Don't tell me you fold. So what it's doing, it's loading all of the data at once, right? So it doesn't have to reload it each and every single time, right? So once it loads all of the data, it loaded all of 2023, right? Again, remember that's over 10 million, it's millions and millions of rows of data that it has to load. Then it has to go to 2024, rows the millions and millions of rows of data, right? Then once it loads this once, it has it in a pre-index or pre-cached. I don't want to say pre-cached. I mean, kind of is pre-cached, pre-index, but whatever. A database, right? That it can just refer to it, be like, all right, I need 23 information. Just drop that to me. I don't have to run it. So what it's doing right now, it's starting the optimization with 100 trials. We're seeding with the best trial, and then its best trial is 0, and then it's running right now, right? So we have running baseline for comparison. Best values 164. Okay. What is this? Oh, the score. Best trial was number 2. So now we have our optimization that is running, right? It says that it's going to take less than 8 minutes. I think you're lying to me. So I'm just going to let this run. So y'all see we're getting best results. And like it went from 2, now it's 5. Now it's interesting to see what is going to happen at the tail end of this. So what I'm going to do is I'm going to let this run, fam. Y'all see that we're at the optimization part of this, right? Where I'm using Optuna to be able to find the best parameters and best configurations for this particular strategy that we're building here. So if you haven't already, I need you to go ahead and smash that like and subscribe button. And we'll be back for part 5 to actually go over the results, what we found. And I'll bring y'all back in towards the tail end of this, if it is actually going to take 7 minutes, which I think is going to be like closer to 12, but okay, we'll see. So I'm gonna let this go and I'll be back. I appreciate y'all for y'all patience, bruv.